graphs of rational functions. There's a process. Consider the rational function f of x equals p of x over q of x. Q of x can't be 0, and p of x and q of x have no common factors. Start off by finding the x and y intercepts. Graph the vertical asymptotes. Use dashed lines. Graph any horizontal or slant asymptotes. Use dashed lines. Find the point, if any, where the graph crosses either the horizontal or the slant asymptotes, and then plot enough points to see the pattern of the graph. The first thing I'm going to do is to factor the numerator and the denominator. So f of x is equal to 4 times x minus 1 in the numerator and x minus 3 multiplied by x plus 3 in the denominator. So I can see there they have no factors in common. To find the x-intercept, that is always the point where y equals 0. I'm going to say that that is, to solve the equation, 0 equals 4 times x minus 1 all over x minus 3 multiplied by x plus 3. If I multiply both sides of this equation by the denominator, I'll see that I actually have to solve 0 equals 4 times x minus 1. Divide both sides by 4, I'm going to end up with x minus 1 equals 0, or x equals 1. So the point that is the x-intercept is the point 1, 0. Next, I want to find the y-intercept. That's the point where x equals 0 on any graph. So f of 0 will give me the y value for the y-intercept. So that's 4 times negative 1 in the numerator and negative 3 times 3 in the denominator. So f evaluated at 0 is positive 4 ninths. So the point in question is 0 and 4 ninths. So the x-intercept is the point 1, 0, and the y-intercept is the point 0, 4 ninths. Next, I want to find the vertical asymptotes. They are the lines that the graph cannot cross, and they are also the points where the denominator is 0. So I have x is negative 3 and x is positive 3 are my vertical asymptotes. So the graph cannot cross the line x is negative 3, and it cannot cross the line x is positive 3, the vertical asymptotes. Next, we want to consider the horizontal asymptote. Since the degree of the numerator is 1 less than the degree of the denominator, in this case, then the horizontal asymptote is y equals 0, the x-axis. If there's a horizontal asymptote, there's no slant asymptote. If there's no horizontal, there may or may not be a slant asymptote. But we'll indicate our horizontal asymptote, which is the x-axis with a dotted line, y equals 0. The next step is to plot points, and I use the calculator to speed this up. If I hit up y equals, I put my original function in the y equals, or y1. Second quit gets me back to the home screen. And now I'm going to have the calculator automatically find me a series of points. Second table set, I want to start at negative 5 because I know that the graph is undefined at negative 3. So I want to go a little bit left of that. And this next part, this little delta, this is the Greek letter delta, means add 1 to negative 5 and keep doing that. Instead of ask, I want auto, so it's automatically going to generate numbers negative 5, negative 4, negative 3, negative, and then it'll calculate the y value. Independent variable is the x, dependent variable is the y. Second quit gets me back to the home screen. If I want to see that table of values, second table. So negative 5 and negative 1.5 is a point. So now at this point I can start writing down some points from my calculator. Negative 5, negative 1.5, and then I would have negative 4, negative 2.857. I'm just going to round that off to 6. I continue to write down the points till I have as many points as I think that I need to graph my function. And of course, I have a calculator, so I can just go ahead and use the calculator to do the graph. So this will give me an indication of what the graph should look like. If I hit the zoom key, that'll give me a choice of graphing windows. Z standard is x is negative 10 to 10, y is negative 10 to 10. And I know the graph should look something like this. So then if I plot the points, I can connect them with the appropriate lines. And there's my graph.